Our next example is a velocity problem. This one I particularly picked, I think it's number 14 in section 2.7 in the book, because it starts out by talking about the average velocity and then secondly asks about the instantaneous velocity. So the average velocity is just going to be that ordinary ratio, right? Like we did back in section 2.1 or whatever. So they give you an interval and you want to find the average velocity. So I'm going to do my average velocity for, I want to label them. For 8, velocity, the average velocity, it's going to be s of 8 minus s of 4 over 8 minus 4. So you're just going to plug those numbers into there and figure it out. So I plugged this in. I don't know. I'm just going to plug it in. I actually did them before so that I wasn't sitting here doing arithmetic for a million hours, but just, and then over 8 minus 4, which is 4. Well, it turns out if you work this out, it actually is 0. And then if I'm looking at this for 6, 8, it's not going to be 0. But again, what do I have? That's a 64 over 2 minus 674, 23 minus, now I'm going to have 1/2 6 squared minus 6 times 6 plus 23. So again, the 23's cancel out. Eventually, this ends up being 2 over 2 or 1. Okay, 0 or 1, fine. So that's how I do those. You all know how to do those. These things should have units, right? It's an average velocity. So it should be feet per second. I'm going to put it up here because I need the space to do the limit. So this was 0. And this was 1. And if I really wanted, as I know you guys did it back in section 2.1, but I'm never going to ask on a test or anything. If you really wanted, you would, to illustrate what was going on, if this was actually approaching something at 8, you would take much smaller number, much closer together numbers, right? So I would want 7.5 and 7.99, and then I could get some idea of what was really going on there. Now for number 2, we want to find the instantaneous velocity. So exactly, we said that that was the derivative, s prime of 8. And in fact, often we call it velocity v, so v of 8, but I'm just going to call it s prime of 8 now. So I want the limit as h goes to 0 of s of 8 plus h minus s of 8 over h. And I then just put all of this stuff into this difference quotient. So I end up with 1/2 8 plus h squared minus 6 times 8 plus h plus 23 minus, by the way, notice that when I do this, I always put in the parentheses even when I'm stuck here and I don't have any space left, because probably the most common mistake on these is forgetting the parentheses, and then you don't get your negative all the way through, and then you have the wrong answer. So it's a really silly error, but very, you can fix it easily enough as long as you use those parentheses and remember to distribute your negative. Okay, so if I work this out, what do I have? I have 1/2 times 64, and I'm going to do 2 steps in one, right? Because this is 64 plus 16h plus h squared, but I've got a 1/2 in front of it. So I'm just going to write the 1/2 so I don't screw it up in my head. Times 16h plus 1/2 h squared minus 48 minus 6h. These guys we already know they cancel out, right? Minus 64 halves plus, see, 48. So this one is a plus 48. Plus 48 cancels minus 48. These guys cancel out. And now I can collect these a little bit. I've got plus 8h minus 6h. So that's going to be 2h. And this is just 1/2 h. Whoops, add 1/2 h squared. But now you see there's an h in everything. So I can pull an h out of the top. And then I can cancel them out, or I can cancel out however you want to do it. What you end up getting, that h in the bottom cancels out, I end up with 2 plus 1/2 h, and as I let h go to 0, I get 2. Okay? So that is the instantaneous velocity. Now, I did want to point out sort of the relationship, right, between these two things that we were talking about, one being the tangent problem, the other the velocity problem. So let me show you. I just let me see here. And we also had these other pieces of information about these guys. So let's, why is it not working? Oh, there we go, there we go. There we go. So this is, of course, I'm using x instead of t, but this is the equation which is giving us our displacement of the particle. And you can see, I don't know, can you see? Is it low down enough? Zoom out a little bit. Okay, so you can see here's the point at 8 that we're interested in. And all right, so here's the point at 8. So if I draw the line between, here's the point at 4. So if I draw the line between the point at 4 and the point at 8, it actually does that. And in fact, that does have a slope of 0, which is what we had found, that it had a slope of 0 if I did the average velocity between 4 and 8. Now, if I go through the point at 6, that's this bottom point, right? So my line, if I draw the line, it should be going that way. And there it is. So that's like, that is the line. The slope of that line is the velocity between those 2 points. And then my actual tangent line is that one. That is the one that has the actual, it gives you the actual velocity at the point. Okay? That, and as you can imagine, if I look at what this particle is doing, this particle is moving this way, right? Okay. It's moving this way, but it's moving in a straight line. So you have to think about this as being the particle's position is the y-axis, and this is time. So it's the position at time going on a straight line. It's not actually moving along a parabola. Okay, so let's just be clear on that. I don't want to, I'm just trying to clarify it with the picture. I don't want to confuse it with the picture. It's definitely a particle moving in a straight line. It's moving, so it's like it was moving over at 15, and then it was moving down to 5, and then it comes back and it starts moving over again. So that's the motion that we're thinking about. If you're thinking about what the particle actually is doing in, well, it's not real life. It's a mathematical example, but you know what I mean. Okay, let's stop with that one.